Hello everyone, November 28th. Alright. I hurt myself. I did a little bit too much yesterday on a jerk. So I think I hurt my right shoulder blades. And today I did a lot of snatch. Way more. I think program is asking for 3. I think I did, 20. So I feel broken at the moment. Very broken. Everything hurts. And kind of late, so we're gonna do this, and once we're done, maybe we can, try this one again. The nested iterator. Oh, I forgot how this one is done. Absolutely forgot. All right, what's this? Write a function that takes the binary representation of an unsigned integer and returns the number of 1 bits it has. There's no unsigned integer type. In this case, input will be given as a signed integer type. It should not affect implementation as integers' internal binary representation is the same, whether it is signed or unsigned. In Java, the compiler represents the signed integers using 2's complement. Therefore, in example 3, the input is a signed integer, so it doesn't really matter, right? I mean, we shall just check. Say int n equal to notation of the signed integers minus 3, right? We can say n dot. Well, actually, I don't know how do we do this. Java binary, no, int to binary string, integer dot to binary string n. Yeah, and this dot count. How do we count bits? Count bits. Dot bit count. Oh, hold a second. There's a method called bit count. Dot bit count a. So which means I can just say integer dot bit count and big count. It's not big bit. There we go. So I think I only need to do integer dot bit count and let's make sure it works. Oh wait, hold a second. Oh, it is correct. Wait, what's the input? The input is an int. A binary representation of an input. Ah. All right. Nah, I don't want to think more about it. We've done it. That's it. Oh, it's the Python solution. Oh my goodness. Count one, yeah, exactly. Okay. This is the real one. This one requires some thought. Yeah, nested list. Each element is either an integer or a list, whose elements may also be integer or other lists. Implement an iterator to flatten it. So we don't implement an iterator. We just flatten it, right? We just flatten it. The iterator part is not necessary, okay? The iterator part is not necessary, so we just flatten it. And I remember it's a and what function we can call is integer, right? We can call is integer, get integer, and get list. So we're given this, if I remember correctly, we go back to front. That's what I remember, right? So you have a nested list, right? So we have 1, 1, 2, let's call it 3, 4, okay? So we'll put back to front. So we go 3, 4, 2, and a 1, 1. So this will be our stack, right? And now we pop the last out, 1, 1, and we'll ask, is this a list? Is this an integer? Right? It's not an integer, so we will get the list, right? We'll get list and wait, hold on, get the list will give me another list of integer, and then we push it in, right? So we get list, and then we push it in 1 on 1, and then we pop again. Is this an integer? It is. So integer, push it in. Is this an integer? Yes. Is this an integer? Yes. Is this is no? So we pop it, so it becomes 3, 4. Is this an integer? Ooh, you get 4 first. So once you pop out, is this an integer? It's not. So when we push in, I shall always push the and in first, right? So we push 4 in and then 3, and then we pop, so 3 will come out, 4 will come out. Okay, so that's the function, right? The function is called unnest, okay? Which means we given a list of nested integer, right? We given that. We will go from the right to left, and each time we get out no, we pre-process it. We put everything into a stack, okay? We put everything into a stack, and then we say unnest, right? Unnest, and we will unnest, we unnest a list of nested integer. So we unnest that. What we do is we take everything from right to left, push it into a stack, okay? And then we'll always do this first, and then we'll pop the end, right? We pop the end, and if it's an integer, we push to the unnested, right? We push to the unnested. If it is not an integer, we call it again, right? We call it again, which is a nest, which will just, because we will get the list, and then we push it again, and then we from right to left, and we will get it, and then we push it in, right? We get it, and then we'll push it in, and then we'll start calling. Okay, so maybe let's try this. Let's try this. So it will be awkward because we don't have all the functions, but I think it's fine. Yeah, it's okay. So what we need to do first is we need a stack, right? And call it stack of nested integer. Okay, so we call it stack. Right, so we have a stack and we have a list of integer, which is unnested. Okay, then we have a private function. We call it, it's gonna be a void unnest, which will pass in a nested integer. Right, we'll pass in a nested integer, nested list. Okay, so what do? We'll always go from right to left and push into the stack. And we can say for int I equal to nl dot size minus 1, I smaller than, no, larger equal to 0, I plus plus, and I minus minus, right? So what we do is nl dot get I, we're gonna push, so we'll say stack, right, dot push, dot push this. Okay, once we do that, then we'll say while stack, right? Boom, 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 boom. We push everything from right to left, we push it in, and then we say while stack, and we'll pop it out, right? We'll pop it out, and then yeah, while stack dot is empty, right? We're gonna say nested integer ni. Okay, nested integer n shall equal to nested integer equal to stack dot pop. Okay, if ni dot is integer, okay, if ni is integer, then unnested dot add ni dot get integer. Right, else yeah, I think it's fine. Else and that is not integer, then we call unnest ni dot get list. All right, we just call it, and then we'll call this again, and then we'll try to, do the stack, and eventually if the stack is over, then all the other one will get it. Yeah. So we do this, and here we'll basically just call unnest nested list. Okay, so this one will give me unnested, and then we just need to get an oh, what did you do? That's not right. So int index is equal to 0. Okay, and then we go to 20, the next. So we just return I mean, we probably should check, but I think this, it was said like always work, right? Yeah, I think this can just return, return what? Unnested dot get index, right? And then after I get it, I'll plus plus. All right, and then this is pointing, so to return index is smaller than unnested dot size. Okay. Let's see. It's good. Is it working? I think it's working. Yep, it's working. Okay, check our previous result. Oh, it's almost a month ago. Okay, internal, we have a stack, we have an index. Oh, we call it flatten, that's a better name. Or stack or push. Top is integer, we'll add, else we'll flatten again. Yep. Okay. Good. Good. That'll be it. It's late. I'll just end today here. I will. Oh, what's the next one? Count of integers. Skip. We are going to skip and then do this instead. Right? We're going to skip that and do this instead. We'll get back to this some other time. Lord, look at this. Look at this. The amount of. Yeah. Yeah, we'll deal with this another time. We'll do this. We'll do that. We'll do all of this, but except doing this. Yeah, it's, you know. And then also we all have this problem to solve. Oh my goodness.